In this video, we will delve into the first come, first served, often abbreviated as FCFS scheduling algorithm. We will explore its implementation and analyze how it works as a central processing unit scheduling algorithm. Let's understand what first come, first served scheduling really means. First, it is the simplest central processing unit scheduling algorithm. It follows a non-preemptive scheduling policy, meaning once a process starts, it runs until completion. Processes are executed in the order they arrive. This is typically implemented using a first-in, first-out, often called FIFO queue. This makes it easy to implement and understand. Now, let us examine its advantages and limitations. It is considered fair for processes that arrive earlier. It is simple to implement, often using a queue data structure. However, it suffers from the convoy effect where short processes might get stuck behind long processes. It is not optimal for response time, as processes are handled strictly in order, and it does not consider priorities among processes. Let's consider an example to understand first come, first served scheduling better. Here is a table of processes with their arrival times and burst times. Process 1, indicated as P1, arrives at time 0 and requires 24 units of time to complete. Process 2, indicated as P2, arrives at time 2 and requires 3 units of time. Process 3, indicated as P3, arrives at time 4 and requires 6 units of time. Now let's visualize this using a Gantt chart. Process 1 occupies the central processing unit from time 0 to 24. Process 2 then runs from time 24 to 27. Process 3 then completes the schedule from time 27 to 33. Let's calculate the performance metrics for the previous first come, first served scheduling example. First, we will calculate the waiting time, indicated as WT for each process. For process 1, it is 0 minus 0, which equals 0. For process 2, it is 24 minus 2, which equals 22. For process 3, it is 27 minus 4, which equals 23. Therefore, the average waiting time is 0 plus 22 plus 23, divided by 3, which equals 15 time units. Next, let's calculate the turnaround time, indicated as TAT, for each process. For process 1, it is 24 minus 0, which equals 24. For process 2, it is 27 minus 2, which equals 25. For process 3, it is 33 minus 4, which equals 29. So the average turnaround time is 24 plus 25 plus 29, divided by 3, which equals 26 time units. Let's examine a basic implementation of the first come, first served scheduling algorithm. We start by defining a structure named process, which includes the process ID, arrival time, and burst time. Next, there's a function named calculate waiting time. It takes an array of process structures, the number of processes indicated as N, and an integer array named WT, to store the waiting times. The waiting time for the first process is 0. The waiting time for each subsequent process is calculated as the burst time of the previous process, plus its waiting time. Continuing with the first come, first served implementation, let's define the function to calculate turnaround time. This function named calculate turnaround time takes the process array, the number of processes, the waiting time array, and an integer array named TAT to store the turnaround times. The turnaround time for each process is calculated as the burst time plus the waiting time. Finally, the function calculate average times computes the average waiting and turnaround times. It calls calculate waiting time and calculate turnaround time and accumulates the total waiting time and total turnaround time to later calculate the averages. Let's analyze the advantages and limitations of first come, first served scheduling. Some advantages are, it is simple to understand and implement, requiring no complex calculations. It is also considered fair for processes that arrive first, And every process gets central processing unit time, which means no starvation. However, the limitations include the convoy effect, where short processes wait behind long ones, leading to poor average waiting times. It is not suitable for interactive systems where response time is critical, and it does not consider priority. In conclusion, first come, first served is best suited for batch systems where response time is not a critical factor. If you like this video, hit that like button and don't forget to subscribe. Visit codelucky.com for more such useful content.